I want to point out here and just talk about what self is doing here, because you might look at this and wonder, okay, why is this attack self comma car2? This has two parameters, but when we call the function, we actually call it with just one argument. What's going on there? Well, class methods are very special. The generic form, and this is just the template that you can look at and remember, is when we're defining a class method, this method has a name, and the first argument, or first specified parameter, the first specified parameter is always self. By the way, it can't be named anything else. It has to be the word self. This is like a quirk of Python. So inside of your function, inside of your class, any methods that you define have to have their first parameter be self. And then when you call this class method, self will be filled in with the object that you're using to call the method. This is how you refer to yourself. And you can kind of see this in this attack method. I'll point out, you need this self to be able to get your own strength, to figure out how much damage you're going to do to whoever you're attacking. So this self gives you that reference. And so when you call a method, when you do woody.attack Mickey, you get the self part. Python gets it from the fact that you're using Woody to call this method, woody.attack. And then in the actual parentheses where you pass the arguments, you only pass arguments to fill in the parameters after self. So self is always the first thing, and you only need to pass in stuff after self. That's why there's only one argument passed into this method, this attack method. Yes, so our general form here looks like def function name, then self as the first parameter, and then 0 or 1 or more parameters, just like in a regular function. And inside of your function body, in all your lines, you can do whatever you want, but whenever you want to refer to yourself, you use the word self, because it's one of our parameters. Fun fact is, you've actually been using this all along. You've been calling these methods. You just didn't realize it. One of the first ones that I taught you was for strings. String is actually a type of class. It's a built-in type, and so it's a little different. And so I don't want you to think too much about, okay, is it a class? Is it not a class? It has our methods, though. For example, .upper. .upper will take the string and it returns it as all uppercase. Or .lower. .lower takes the string and returns it as all lowercase. These are both methods. And that's why you never had to pass anything in. Notice you didn't have to do like upper and give it the string. It has the characters in the string because you're using school to call .upper. And so actually, if we were to look at what the implementation of .upper looks like, probably would look something like this. I implemented it myself. Def upper, and it takes self. So probably would go through and for car in self dot characters, because remember, a string is really just a sequence of characters. So there's probably some sort of list that when you create a new string, however it works in Python, whatever it takes in, we're going to kind of ignore this here, but it probably creates a list of characters using the characters that you kind of use to initialize the string. And for each of them, it's just if car is lowercase car, result stir. If it's lowercase, then plus equals, I don't know, car dot upper, else result stir equals car. So uppercase characters we keep, lowercase characters we make uppercase. And then it probably just returns result stir, something like this. So this would be probably a potential implementation of this upper method. And that, again, is why this method never took anything in the parentheses, never took any arguments, because the string is already part of the object that you're using to call the class method. Now, a word on terminology. You'll hear people talk about classes or types. These are, in Python, effectively synonyms. So types are like built-in types, strings and objects and strings and ints and floats and bools. And we saw this because if I go back here, I can come here and I can make a new word equals hello world. I can do print type word. I can also say num students equals 10. So let's just make it more accurate. We have about 165 students now. Print type num students. And you can see, yeah, so these types are even actually classes themselves. And so usually when people say types, they're referring to the built-in types in Python, but these are also classes. They also have a class definition, similar to classes that you're creating. And so when we create our own class, just like we made clown the other day in our last lecture, def nose equals big and red. If I make a new clown, I'll add a init method here. Self name. Maybe I'll just name this clown1, like this. Well, if I do print type of clown, yeah, you can see that this is a clown class. It has this underscore main underscore dot. It's just kind of used to show that you defined this this class yourself, versus the built-in classes or the built-in types don't have that prefix. But you are creating your own type. You are so powerful now that you're able to create your own types in Python. And that opens so many doors. Because now you're not just restricted to only representing the built-in types. You can represent any kind of object in the world by creating an object or a class in Python and making instances of that class. The other thing I'll point out here that I just kind of almost, I hinted at in the way I just used my words, is the difference between a class instance and a class definition. The definition of a class is like a template. It describes what data is in that class. It sets up, provides routines, the class methods, functions. Whereas an instance of that class is when you actually create an instance of that class. It's easier for me to show this as an example. Think of a string. So the string, a string, is a data type. So it's the class definition. And it's a data type that holds on to a collection of characters. And it has an upper class method, a lower method, so on and so forth. An instance of that string holds on to a particular collection of characters. And so like here, all three of these variables, so name, school, and semester, these are all three instances of the same type. So the type here is string, and these are three separate instances. And so these are also known as objects.